Dear followers, in this part of the lecture, we will talk about an example of a connected home. It is a real system that we installed in many buildings, and this example will help us to illustrate later the diagram of analysis and design. What is a connected home? We didn't use the word smart because we think that it is better to talk about a connected home. There is different objective. For example, energy saving, enhance quality of life, increase security. This may be at an individual level, but we have many levels. Our goal is to better understand the house, the building, the neighborhood, the city, in order to improve our houses, our neighborhoods, our cities, our world. So it is not individual goal. We installed this system in many buildings, in some social housing, in some schools, in the university, in some houses of elder people. The goal is to collect data. So collecting the data, it is the goal of this system. What is the goal of this data? It is to make local analysis. We see here that it is not only the collected data from the system that we use for the analysis. We need a huge quantity of data. For example, about if we want to analyze the social structure, we should understand the goal of the building. We should understand the nature of people who are installed. We should communicate with these people. Regarding the nature of the building and the goal for which it is used, we use the suitable data. We try to search the suitable additional data in order to make the local analysis. We should pay attention that at first we try to collect the data at local level, because there is a question of rights. We talked before in this lecture that a building or a house, it is not merely a building, but it is an intersection of many systems: social, economic, administration, etc. After collecting data locally, we can collect the data in a central database. This is related to the question of rights, because every apartment, for example, may have its own rights for the measurements. What happened at the central database? What we also add necessary data in order to make a global analysis. We can get an idea about all the building, or all a neighborhood, or a specific system, social houses, for example. What is necessary also here in the plus data, we can add some additional connected information that comes from a global sensors. For example, the common parts of a building, the global part of a building, the gates, etc. So at the global level, sometimes we have a global heating system for a residence, for example, a social residence, etc. What is the goal? The goal of the analysis is to make recommendation. As a researcher, our goal was to make recommendation in order to improve the situation. The importance of the connected system, it is not only its own data, but the position of these data in the global context. Some types of parameters that we measured and we are measuring now in our research. For example, as you see in the left part, we have water consumption and electrical consumption. We can make this measurement with some simple devices. For example, we have here a water counter. It is a specific water counter. Not all the water counters have this ability. We can add a head to this counter, and when we add this component is connected to a wire, and we add here, for example, we add here a sensor, and this sensor can send a signal each time 1 liter is consumed. We have also electrical meter. You can see also the electrical meter. Before we used this sensor under the electrical meter in order to send the data, but electrical meter are being developed, and now we can get this data from the cloud. But we have another interesting sensor regarding the electrical consumption. Instead of getting data from the electrical meter, we can add this component. We can put it in the electrical board, and it can measure the electricity that come through it, and it can sense the consumption immediately with wireless, and it does not need a battery. We have also temperature, luminosity, humidity. Before we used this type of sensor, we designed it. As I showed you perhaps before, this is a temperature and a humidity sensor. Beside it, there is a luminosity sensor, and here is the acoustic voice sensor, and there we have the possibility to add CO2 sensor. This is CO2 sensor, for example, but this sensor needs a feed of 12 volt, so it is a little bit complicated. We replaced it with this sensor. This sensor can measure temperature, humidity, luminosity, noise, and CO2 at the same time, and it can communicate it immediately to the cloud. We have also a sensor to detect if a door or a window is open or closed. It contains two parts. One is magnetic, and the other is a circuit with a wireless emitter in order to send the state of the door. The principle is very simple. In one apartment, we have many parts. We can add what we can call adapter, 1 or 2 adapter. Each adapter or module may contain 1, 2, 3 sensors. It depends on our needs. We choose wireless sensors, and these sensors will communicate the data into a central unit. The goal is to store this data in this central unit locally. So we don't prefer to use the cloud. It is a question of rights, but if we use a cloud, we try to protect the privacy of each inhabitant. After that, the user, it is very important. With this system, the user, the inhabitant, can know immediately what happened in his house, so he can take action. And this may improve the situation in houses. So using a suitable tablet or any smartphone, he can know what, or a computer, he can know what happened in his house. The central unit in our system is a very small computer and powerful computer and cheap computer. It is in the availability of any person. This is the central unit. It is a Raspberry Pi. What is a Raspberry Pi? It is a small computer. As you see here, we have the USB port, HDMI to connect a screen, and it is very cheap. 2 years ago I read that it will arrive to $5, but for the moment the price is almost $40. We add the necessary component on it to receive the data from our sensors, and what type of, we can see the hard disk of this sensor. This is the SD card. It is the real hard disk of our system. So we can put, as you see, we can put it here. We can put it here. It is a real hard disk of our system. All this system, the server, if you can call the Raspberry Pi, with all the other components, it costs less than $100. So relatively it is a cheap system, and this Raspberry Pi, we can install Linux on it, so it is really a complete computer, and we can use for other purposes, for any goal for which we use a PC. In our Raspberry Pi, in the system, we have some application in programming languages, and we have a database, and we have programs to communicate with the user. We have another type of programs that we didn't show here. It is the communication with a central database, but this may be made by a human also. So the sensors send data to the programs, and these programs can verify this data, can convert this data, because when we receive a data from a sensor, it is in binary. So we try to convert it to verify if these data are correct or not, if these values are acceptable or not by this Python, because sometimes we have some errors. So Java and Python or other programming languages can check these data, and they can add the timestamp, because the sensors don't have clock. So we try to register all the data, and sometimes we make some modification. For example, if we receive the water consumption by liter, we can convert it to, for example, to have the consumption each hour or each minute or each week. It depends on our needs. So the programs receive data from sensor, they add the timestamp, they verify if these values are correct or not, they convert it from binary into human readable values, and they put them in the database. The user from his side can connect to communicate with the user-friendly interface that we developed, graphical user interface. He can see his house, and he can see the temperature and humidity in each part of his home, and these programs communicate to the database to get the necessary values. The user, for example, can precise the range of time, he can precise a specific date, he can search the means of some values. He can have a global idea about the consumption of in 1 week, in 1 year, in 1 month, etc. So these needs are satisfied by the GUI interface. We have also, the sender also, the user can send some comments, so can change something in the home using actuators, so can increase the temperature of the heating. He can switch on or off an electrical device. But this part of the system is not very important for us, and it is related to the rights. So we, in most of our system, we don't active this part. We should not forget that our system also should communicate the data automatically or manually with a central database, but this question depends on the filter that we will put, because it is related to the data rights. This is an example of the installation. We add many sensors in one apartment. Here we add the air quality sensor. We add temperature sensor in many positions. Sometimes it is in a high level, in low level, behind the heating. As you see in the photo to left, bottom left, we add a sensor to detect if the door is opened or closed, and we put a temperature and humidity sensor outside. In each apartment, we adapt the installation regarding our needs and regarding the situation of the apartment. Sometimes we add more humidity sensor, for example, in the kitchen and in the bathroom. Here is some examples in the bottom, the readings of the sensor that we installed in the outside and regarding the internal temperature and external. To compare the internal temperature with the external temperature, we can see that the internal temperature is related to the mean of the external temperature, the air quality and luminosity. So from luminosity we can detect the presence of people, and we can match between these two parameters, etc. We can combine a lot of parameters, and we can use all the opportunity of data analysis. These diagrams, for example, show the relationship between the humidity and the temperature, and it is very important measurement regarding the comfort and the health in an apartment. So it is an accumulated values during 1 month or 1 year, and we can project this accumulated value in the reference diagram of the indoor health, and we can see that our values are in the violet zone, most of them, which is healthy. But we should pay attention, because some points are not in the healthy zone and they may be dangerous. When we analyze these points, we find that it represents almost 4% of the global points, and we find that it is related to the using of kitchen in the evening. So we could give advice to open the window during this period for 5 minutes, and it could improve the situation.